Hello, welcome to my channel Biographia. My name is Shayan, and in this channel I aim to cover the various topics and chapters of CBSE and ICSE biology. So please stay tuned as I will slowly upload videos that will cover the entire syllabus across various standards. Hello, welcome back to my channel Biographia. This is a side video where I will explain what a hydrogen bond is. So hydrogen bond is a part of chemistry, but it has recurring appearances in biology chapters. So I will provide you with a brief description of what an hydrogen bond is. To understand an hydrogen bond, first we will have to understand what is chemical bonding. To start with that, I will have to give you a brief on what atoms are, what is atomic number, and their valency electrons. So at class 10th level, you will have to first memorize the first 20 elements of the periodic table. So I am doing this for quite a long time now, so I have memorized all of them, but please make sure that you have remembered all the periodic table elements, not all, actually the first 20 elements, in a orderly manner. So these are the first 20 elements. Now let us put the atomic numbers. So it starts with hydrogen, which has an atomic number 1, helium atomic number 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, and calcium 20. So what is an atomic number? An atomic number is nothing but the number of protons in the nucleus of an atom. So if we take few elements from this, for example, let us take sodium, Na, then carbon, oxygen, hydrogen, and chlorine. If we take these 5 elements, so based on their atomic number, what we can derive is the number of protons that they have in their nucleus. So sodium has an atomic number of 11, carbon 6, oxygen 8, hydrogen 1, and chlorine has an atomic number of 17. So from this we can tell that the number of protons in a nucleus of sodium is P equal to P for proton 11, P equal to 6. So whatever the atomic number is, the element has exactly the same number of protons in its nucleus. So atomic number is nothing but the number of protons in a nucleus of an atom of a particular element. Now, what else can we get from the atomic number? So, the number of protons P is equal to the number of electrons of an atom. E. So, atomic number is equal to the number of protons, which is in turn equal to the number of electrons a atom of an element has. So from this we can say that sodium will have 11 protons and equivalently it will have 11 electrons. Now let's go to the structure of these elements. So electrons are arranged in several shells or orbits around the nucleus. And this arrangement is in numbers of 2, 8, 8, 16. So these are the separate shells which are named as K, L, M, N, and it goes on. So since we are dealing with the first 20 elements, I won't go further than the N shell or the fourth shell. And now we will draw what the atoms look like. So let us start with the first one, the smallest element, hydrogen. So hydrogen has one electron. So this is an hydrogen nucleus where the proton number is 1. So now how are the electrons arranged around this proton? So since hydrogen has one proton, it will have one electron. So it's not that difficult. K shell can accommodate a maximum of 1 electron. So since hydrogen has only 1 electron, it will go in the K shell as 1 electron. So around the proton, only 1 electron revolves around hydrogen. Now let us go to the next one, carbon, which has a atomic number of 6. So the K shell can accommodate a maximum of 2 electrons. So out of 6, the K shell will have 2. What's the remaining number of electrons? 6 minus 2 is equal to 4. So the next shell will have 4 electrons. So carbon nucleus will have a proton count of 6, and around that it will have 2 shells. Unlike hydrogen, carbon will have 2 shells. The first shell will have 2 electrons and the next one will have 4 electrons. Now if we move on to a higher element, oxygen, which has an atomic number of 8. So the first shell will have 2, maximum 2, done. The next shell can have a maximum of 8. So there are a total of 8 electrons in oxygen. So 2 have gone to the first shell. The remaining 8 minus 2 equal to 6. So the next shell will have 6 electrons. So the structure will look like proton count is 8, and around that 8 proton nucleus we have 2 shells. The first shell has 2 electrons and the second shell has 6 electrons. 1, 2, 3, 4, 5, 6. Next is sodium. Atomic number 11. Two in the first shell, maximum. In the first shell we can't go over 2, so the first shell will have 2 electrons. The next shell is 11 minus 2. The remaining count is 9 electrons, but the second shell can accommodate only a maximum of 8 electrons. So 9 is greater than 8, so the second shell will have 8 electrons. And when we move on to the third shell, we have 9 minus 8 is the remaining electron, that is 1. So the last shell will have 1 electron. So a total of 2 plus 8 plus 1 is equal to 11. Proton count is 11, and around that in 3 shells. So when the atomic number increases, the number of shells increases step by step. We have 3 shells. The first shell will have 2 electrons. The second one will have 8. So all these electrons are orbiting or revolving around the nucleus. 8, and the last shell will have 1 electron. So this was oxygen. And this was sodium. Next we have chlorine. 17. So it will be 2. Next one will have 8, 10, and the last shell will have 7. So it has a total of 17 electrons. Minus 2 is equal to 15, and this one will have 15 minus 8 equal to 7. So that's why 7. So here number of protons 17, and around that nucleus we have again 3 shells. 1, 2 in the first shell, 2 electrons. The second cell will have a complete 8 electrons, and the third shell will have 7 electrons. So this is chlorine. So this is the basic way we draw atomic structures. So now let us draw a structure of a unique element which are called noble gases. These three, helium, neon and argon, and there are other noble gases as well, but in the first 20 elements, these three are the noble gases. And why are they called noble gases? So let us take neon for example. Neon has 10 atomic number. So it will have 2. First shell 2 electrons. The next one can have a maximum of 8. So it has 10. So it has remaining of 8 electrons. So these 8 electrons will go to the second shell. So there is a nucleus of 10 protons, and around that in 2 shells or 2 orbits there are 10 electrons. 2 in the first shell and 8 in the next one. So what is the difference between neon and the rest of the elements that I drew here? So neon has a completely filled outer shell. What is an outer shell? The last orbit of each element is known as its outer shell. So hydrogen has only one shell, so that will be its outer shell. Carbon, the second shell is the outer shell. For sodium, chlorine, the third shell will be its outer shell. So noble gases always have a completely filled outer shell. What that means is that this is the L shell, this one is the K, and this one is the L shell. So the K shell can accommodate maximum of 2 electrons, and the L shell can accommodate a maximum of 8 electrons. And noble gases have that maximum number. So K shell can have a maximum of 2 electrons, neon has 2 electrons in its outermost shell, and L shell can accommodate a maximum of 8 electrons, and it has 8 electrons in its outermost shell. So neon, helium, argon, these gases have a completely filled outer shell. And what difference that it makes? Having a completely filled outer shell gives the element stability. It becomes stable. That's why the name is given noble gases. Noble in the sense it won't react with any other elements because it doesn't need to react. It has a completely filled outermost shell. But other elements who don't have a completely filled outer shell, like hydrogen, it has a K shell which has 1 electron, but K shell can have a maximum of 2 electrons, so it has 1 electron short. Carbon, the K shell has 1 and the L shell has 4 electrons, but what is the maximum number of electrons the L shell can accommodate? It's 8. So similarly, all the other elements have a deficit of electrons in its outermost shell. They don't have a completely filled outermost shell. So they need to exchange electrons among themselves to achieve the configuration of a noble gas. For example, sodium. Sodium has 2, 8 and 1 electrons. So it has a deficit of electrons in its outermost shell. So it has 2, 8 and 1 electrons. So in order to achieve a completely filled outermost shell, it can either subtract one of the electrons or take in electrons. So if I subtract one electron, I will have 2, 8. So this is a stable configuration. So one shell is removed and the remaining shells are completely filled. Again, what is the other option? It can take in electrons. So what is the maximum number of electrons that the third shell can have? The third shell can have a maximum of 8 electrons. So it has 1 electron. So it can take in 7 electrons. So either it will subtract 1 electron or it will take in 7 electrons. So if it takes in 7 electrons, the configuration will be 2, 8, 8. So this is also a completely filled configuration. So which one is easier, to kick out 1 electron or to take in 7 electrons? So depending on this, an atom will either kick out its electrons or take in electrons from other elements. So here kicking out 1 electron is easier than taking in 7 electrons. So sodium will try to achieve this configuration by removing the 1 electron that it has in its outermost shell. Similarly, chlorine, it has 2, 8, 7. So chlorine will try to take in 1 electron or remove the 7 electron it has. So by taking in 1 electron, it will achieve 2, 8, 8. The last shell had 7, it's taking in 1 electron, so the 7 is rising up to 8. And if it removes 7 electrons, it will achieve 2, 8. So again, which one is easier, taking in 1 electron or removing 7? So taking in 1 electron is easier than removing 7 electrons. So a chlorine will try to achieve this formation. So now, how does this affect the atom? If sodium is removing 1 electron, what happens? So the protons, each proton has a positive charge. Each proton has a positive charge and each electron has a negative charge. So since the number of protons and electrons are balanced, say if an element has 10 atomic number, it has 10 protons, which means 10 positive charge, which is equal to 10 electrons or 10 negative charge. So the 10 protons, the 10 positive charges, is balancing the 10 negative charges. So the overall charge of the atom is 0. But when an atom removes or adds electrons, it creates a electrical imbalance, but a stable configuration. So if sodium removes 1 electron, sodium atom will be left with 11 protons, that is 11 positive charges. But since it is, so simultaneously here we will have 11 negative charges, 11 electrons. But if it removes 1 electron, the electron number will change to 10. The electron number will change to 10. So it has more number of protons compared to electrons. So this will create a overall charge of +1. So when sodium removes 1 electron, it will form sodium ion. which has a overall positive charge of 1. Similarly, if chlorine takes in 1 electron, so chlorine has 17 protons, which is equal to its 17 electrons. Now, if it takes 1 minus electron, here we were removing 1 minus electron. Now, if chlorine takes in 1 electron, it will have 17 protons but 18 electrons. So the number of electron is greater than the number of protons, and this will create an overall charge of -1. So this is how ions are formed and elements try to achieve a stable configuration. Now let's move on to the part where bonds are formed. I am wiping the board, so if you want to take a screenshot, you can go ahead. Now, how are bonds formed? There are two types of bonds, electrovalent and covalent. What is the difference between these two types of bonds? First one is the transfer of electrons and second one is sharing of electrons. So, from here we know that sodium will take in. Okay, let's wipe this part out and draw the electronic configurations of these elements. So hydrogen, it has 1 electron, so it will try to empty its shells. So KLM 288. So the K shell of hydrogen will try to make this count as 2 or empty the outermost shell. So hydrogen will remove this electron and it will form +1 hydrogen atom. It is removing electrons. So when we remove electrons, the atom forms an positive ion. Why? Because with removal of electrons, the number of protons becomes greater than the number of electrons. And when electrons are added or taken in, it forms a negative ion. Why? Because the number of electrons becomes greater than the number of protons. So number of positive charges becomes greater than number of negative charges, and here number of negative charges becomes greater than the number of positive charges. So when hydrogen removes 1 electron, it forms a hydrogen ion with an empty outer shell. So only the hydrogen nucleus remains with 1 proton. No electrons in its outermost shell. So you might wonder that hydrogen could have also taken 1 electron, 1 negative electron. in its outermost shell. So that is also possible, and then it forms a negative hydrogen ion called an hydride ion, where the outermost shell has 2 electrons. So that structure looks like this. With an overall charge of -1. Next, if we consider oxygen, oxygen has an atomic number of 8. So oxygen will have 2,6 electronic configuration. So oxygen will either take in 2 electrons or it will try to remove 6 electrons. So taking in 2 is easier than removing 6. So oxygen forms an oxide ion O2 minus, and the electronic configurations becomes 2,8. So since it is taking 2 electrons, the charge is given as -2. 2 extra electrons, 2 extra negative charges. Similarly, sodium has 11 electrons. So it will remove this last shell electron and will form sodium ion 2,8. And next is chlorine 17, 2,8,7. So it will take in 1 electron in its outermost shell and will become chloride ion, which is a negative ion. So from where does these electrons are coming? So we can't create electrons. So elements or atoms, they exchange electrons among themselves. So there are two types of ways in which this can be done. So one is transfer of electrons. And the other one is sharing of electrons. So when electrons are transferred from one element to another, that type of bonding is called electrovalent bond. And when electrons are shared between two atoms, it is called covalent bond. So electrovalent bond forms between elements like sodium and chlorine. So sodium has 281 electrons. So in here, this is called the dot structure. I will only draw the number of electrons it has in its outermost shell. So sodium has only 1 electron in its outermost shell, and chlorine on the other hand has 7 electrons in its outermost shell. I am using a different symbol, dots for chlorine and X for sodium, just to differentiate whose electron it is. So sodium needs to remove 1 electron and chlorine needs 1 extra electron. So sodium will transfer its electron to chlorine, and chlorine, who needs 1 electron, will accept this electron from sodium, and sodium, after removing 1 electron, it will form a sodium ion. And chlorine After accepting the one electron from sodium, it will form a chloride ion. And since positive and negative attract, they will together form a compound with a stable configurations. Here the compound is NaCl or sodium chloride or common salt, the salt we eat, table salt, common salt. Okay, so here after sharing or transferring, after transferring one electron to chlorine, sodium is achieving a stable configuration, a noble gas configuration with a completely filled outermost shell. Completely filled outermost shell doesn't mean the M shell, the third shell, but actually the L shell. After removing one electron, sodium is removing its third shell, and the second shell, which becomes the outermost shell, will become a completely filled outermost shell, that is of a noble gas. Similarly, chlorine takes in one electron and completely fills its outermost shell of the third shell and achieves a noble gas configuration. So that is why noble gas don't react. They don't need electron transfer or sharing. They are already complete. So they don't react with other elements. But here the elements transfer or share electrons among one another to form a compound. A compound will have individual elements who have achieved a noble gas configuration. So when electron is transferred, such compounds are called electrovalent compounds, and the bond formed between these two compounds is called an electrovalent bond. Now, what is covalent bond? Bond formed between elements like hydrogen and oxygen. So oxygen has 6 electrons in its outermost shell. And hydrogen has 1 electron in its outermost shell. So instead of transferring, such compounds tend to share their electrons. It is similar form of bonding, but here the nature of the bond formation is a bit different. What happens is that hydrogen will put forward its 1 electron and oxygen will put forward 1 electron. So by sharing, oxygen now has a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons. And hydrogen also has 1, 2 electrons. That is a completely filled outermost shell. So this type of bond formation is called a covalent bonding, and the compounds are called covalent compounds, where they are not transferring but sharing their electrons. So hydrogen is sharing 1 electron and oxygen is sharing 1 electron. So when an electron is shared, so we will take into count the shared pair for the complete atom. So hydrogen now has 2 atoms. This hydrogen also has 2 atoms, and oxygen has a total of 8 atoms. So this is 1 oxygen and 2 hydrogen. So what is the compound here? H2O, that is water. Okay, so now getting back to the main part of the topic here, hydrogen bond. So I explained all this just for a better understanding of hydrogen bond. So what is an hydrogen bond? So oxygen has shared its electron with hydrogen, and hydrogen has also shared its electron. So hydrogen is satisfied. It has 2 electrons, that is a completely filled outermost orbit. Similarly, oxygen is also satisfied because it has a completely filled outermost orbit, but it has unused electrons. These are called lone pair of electrons. Lone means in the sense alone, lone pair. And because of the presence of such lone pair of electrons, elements like oxygen and nitrogen tend to have a higher negativity. That is, even after forming a bond, it has electrons which is giving it a greater degree of negativity. So if I draw this, it has shared electrons and formed a compound with hydrogen, that is water, H2O. But even after forming this, oxygen has extra electrons which are imparting an extra negativity to it. So because of that, it tends to attract hydrogen of other molecules. So if I take a glass of water, it has many molecules of H2O. So this oxygen, even after pairing with hydrogen, has still some negativity left. So what do negative things do? They attract positive stuff. So oxygen will attract the hydrogen of the adjacent water molecule. Similarly, this oxygen will attract the hydrogen of its adjacent water molecule. And in this way, an additional secondary bond is formed. So this bonding is known as an hydrogen bond. So hydrogen bond is the secondary bond formed between highly electronegative elements like oxygen, nitrogen, and hydrogen atom. So that is the definition of a hydrogen bond, which is a bond formed between highly electronegative elements like oxygen and a hydrogen atom. Oxygen, nitrogen is also a highly electronegative element, so nitrogen also forms hydrogen bonds. So this secondary bond, which is forming between two adjacent molecules, because of the highly electronegative nature of oxygen, it will attract the hydrogen of the adjacent molecule, and such type of bonding is called hydrogen bond. So it is not actually a strong bond like covalent bond or electrovalent bond where the elements are actually bonded. It is a secondary form of bond. So if you want to take a screenshot, you can go ahead, and that's the end of this video. If you have any questions regarding hydrogen bond, do ask in the comments. So it's a recurring word that I will use in biology chapters, so that's why I found it necessary to explain what an hydrogen bond is. I am giving you a few seconds of time. You can take a screenshot or note if you like. So if you like this video, do subscribe to my channel and place a like on this video. And if you have any questions, feel free to ask in the comment section. Thank you. If you find my videos helpful, please like the videos and subscribe to my channel. And if you have any queries or you need clarification with any topic, if you have any form of request, please drop a comment so that I can help you in any possible way. Thank you.